Hi everyone, good evening. So today we are going to discuss about the working of a lithium-ion batteries in electric vehicle applications. So these lithium-ion batteries are the powerful batteries which has high energy density. Okay, so these lithium-ion batteries are designed to support fast charging. So within 40 minutes you can make the battery as full. If you want to perform this action, you need to perform fast charging. If you want to perform fast charging, you need to have high energy density. Okay, so how to understand this high energy density? So energy we can write down it as watt hour per meter cube, and this lithium ion battery has high specific energy. Okay, so they have high specific energy. The units of energy is watt hour. Specific is defined per kg. So since to have fast charging of our electric vehicle and to offer high energy storage for a given length, width and breadth is nothing but metric cube, you require high energy density, and the electric vehicle should offer high specific energy. To have all these characteristics, we are going to select the battery which is nothing but a lithium ion battery. Now let's try to discuss each individual about the battery. So here we have an positive electrode and we have an negative electrode, and separated by a porous separator. Okay, so this separator is nothing but which has some sort of holes, and these are filled with an electrolytes. Okay, the positive and negative are filled with an electrolytes. So now let's try to discuss what are the types of positive electrodes for lithium ion battery, what are the negative electrodes, what are the electrolytes possible. So coming to the positive electrodes, so what are the positive electrodes we have. Okay, let's try to discuss each individual. So at positive electrodes we need to have metal oxide characterized. Okay, so they should be in the form of a metal oxide. So they should be in the form of a metal oxide. So what kind of metal oxides they are? First one is lithium cobalt oxide. Okay, so first metal oxide is lithium cobalt oxide. So you can see here the positive electrode should be a lithium, and the metal is nothing but cobalt. The oxide is nothing but the original. So the lithium cobalt oxide will try to act as a positive electrode. Next, very good positive electrode is lithium ferrous phosphate. So we are going to call it as a lithium ferrous phosphate. So this can be written as lithium ferrous phosphate. So this is also a very good positive electrode which has the lithium, and the metal used here is ferrous, and oxide is nothing but a phosphate. Okay, so the oxide is the form of a phosphate. So that's how the positive electrode should have a metal oxide all the time. Next possible positive electrode is lithium manganese oxide. Okay, so lithium manganese oxide. So this can be written as a lithium manganese oxide, LiMnO. So this is how to classify all the positive electrodes, and let's try to classify the negative electrode. So the negative electrode can be of the below category. So this negative electrode we are going to call it as either we can use an carbon or we can use an graphite. The latest technology is nothing but graphene. Okay, so this graphene comes with a nanotechnology based carbon. Okay, so these are very powerful graphene. This is a very powerful negative electrolytes which are possible. Now, what are the possible combinations of electrolytes also you have to know. So, by properly selecting one positive electrode and negative electrode and electrolytes, we can happily design the batteries with the requirements what already we have been discussed with which supports fast charging, which supports high energy density, and which supports high specific power as well as specific energy. So now coming here, what are the electrode lights? Okay, so we have positive electrode and we have negative electrode and the possible electrolytes, and these electrolytes are specifically of not in liquid form, therefore they are going to called as a non aqueous type of electrolytes. What are those? Let's try to see here. So first one is nothing but lithium. So based upon the combination of these three elements, we can design a new lithium ion battery. Okay, so lithium hexafluorophosphate. So how to expand this? So this you can write it as lithium P F6. F6 is nothing but lithium. Hexa means 6. Fluoride is nothing but F, and P is nothing but the phosphate. So this is the one of the electrolytes. So second electrolyte is nothing but electrolytes is nothing but lithium hexafluoroarsenate mono. So you have to remember this if you want to have a more clarity. So lithium hexafluoroarsenate fluoroarsenate and monohydrate. So this can be shortcut as a lithium arsenate and hexafluoride. You can see here lithium hexafluoride and this arsenate as monohydrate. This arsenate we are going to write it as a AS. So this is how to write down the next electrolytes. So coming to the third electrolyte, which where you can use in a lithium ion battery, is nothing but a lithium percolate. Sir, how to write down lithium percolate? So lithium ClO4 is called as lithium percolate. Next possible electrolytes. Okay, so next possible electrolytes is nothing but lithium tetrafluoroborate. Okay, so how to write down this is a lithium tetrafluoroborate. This borate you can write it as a B. Okay, so this borate I'm writing it as B, and tetra means 4. It's nothing but tetrafluorate. Fluorate you are writing it as F4. This is nothing but lithium tetrafluoroborate. So next possible combination is nothing but lithium triflate. So what is this lithium triflate? So lithium CF3 and SO3 is called as a lithium triflate. So for kind information, you can understand you have three possible combinations of a positive electrode, one negative electrode. It may be an carbon, graphite, or graphene, or the negative possibles is lithium LiPF6, Li arsenic hexafluoride, lithium percolate, lithium tetrafluoride robate, and lithium triflate. These are the possible combinations of electrolytes. Is in between these electrodes, and we have a combination between positive electrode and negative electrode, and these are the possible electrolytes. Now let us try to discuss what is the electrochemistry in this equation. So this is very simple electrochemistry. You no need to have more to understand. So this is nothing but here we are going to have at positive already I discussed, we have cobalt oxide. Okay, so at positive we have cobalt oxide, and this will combine from the lithium ion. So how this lithium ion is going to have is So at negative electrode we have the chemical reaction which is nothing but lithium C6, which is nothing but graphite. It undergoes the decomposition and gets splitted into the graphite. C6 is called as graphite, and the next one is called as a lithium ion, and one extra electron is released. At which electrode? Negative electrode. Automatically the lithium will be absorbed by the positive electrode and negative positive electrode, and the electron also will be absorbed, and this once again undergoes a recombination, and now this battery is in the state of discharging, flowing from left hand side to right hand side. So here the possible recombination we can have is a lithium cobalt oxide, and an extrally an energy is generated. This energy where we are going to call it as a voltage. So like this we are going to have a battery is having higher voltage at one terminal as positive terminal and lower voltages. Then when you connect to an load, automatically the current starts flowing. Therefore I can define the current I is equal to V minus 0 by R. That's how the current flows in the battery. This is how a lithium-ion battery electrochemistry exists, and this is the direction indicates now our battery is in the nature of discharging. Whenever it is discharging, what is available is lithium cobalt oxide, and energy is developed. So if you put the reverse arrow, I can say that it will take energy through an charger and the battery gets charged, and at positive electrode you have cobalt oxide and negative electrode you have lithium graphite. Okay, so this is how the possible combinations will generally takes place. Okay, so you can write down separated positive electrode and negative electrode, or you can directly combine. So if you combine it, I can write down it as a LiC6, and here we have CO, I mean cobalt oxide, undergoes discharging as well as charging. The ultimate byproducts as C6 LiCO2. So this is called the overall equation, which is called, here you can see here, output generated is nothing but an electrical component. Therefore this is called as a electro. So output is electricity, and these equations are chemistry equations. We call these equations as a electrochemistry. This is actually what happens in an battery, and the flow of this arrow mark from left to right shows that the bicomponent developed when the battery is discharging. When you write down the draw the arrow mark like this, from right to left, you can understand the battery is in the case of charging. So that's how a lithium-ion battery can charge as well as discharge. So this is all about the lithium-ion battery. So there's no generally the suitable or the best battery, which is nothing but the LFB batteries. In the market we call it as LFB batteries. So these are very powerful batteries where they offer high fast charging, high energy density, high specific energy, and these batteries do not catch any fire. Okay, so they don't catch any fire with extreme temperature rise. Okay, so due to all these features, these LFB batteries are the more powerful batteries in available in lithium ion segment. Okay, so these batteries are nothing but very powerful batteries, so they never catch fire. If you use a drilling machine on these batteries also, they don't catch the fire in such a way that if you keep inside the microwave also, they cannot catch the fire. That's why the most powerful batteries used in electric vehicle to reduce these fire accidents is nothing but, in technical it is called as lithium ferrous phosphate batteries, which is nothing but LFB batteries. Okay, so this is all about how you select an positive electrode and how you select a negative electrode, and what are the combination possible. In non-aqueous form you can have an electrode as positive electrode and negative electrode, and electrolytes as shown below, and this is the governing energy equations. This is called electro, and these equations are chemistry equations. That's what is called electrochemistry equations. This is how an lithium ion battery can charge of its own and it can perform better. Now hope the video is useful, and we will continue this video with the how to charge and how to charge a lithium-ion battery by using a constant current method and constant voltage method, which is very important. And hope if you feel the video is useful, please give and like, and please share with your friends and give your valuable comments in the comment section. And please subscribe to the channel if you're watching first time. So your subscription is very useful, and this is a free channel and it's not a premium channel. So we offer a quality education as a part of a free education for you, so free knowledge transfer. Please kindly support us to make the channel to grow. Hope we'll meet in the next video, how to charge an electric vehicle. So hope the content is very clear. We'll meet in the next video. Yours obediently, Ram.